All right, so in this part of the lesson, we're going to find the determinant of a 3x3 matrix. So again, looking at this example, I know that I'm going to find the determinant by the vertical bars. So again, if we're seeing that absolute value symbol around a matrix, it's asking for the determinant of that matrix. So for this first one, we're going to do it the long way using our diagonal method. So I'm going to rewrite this one 3 more times. So -1, 2, 0, 3, -4, 1, 5, 6, -1, and then we're again subtracting. I'm just going to kind of copy this. So -1, 2, 0, 3, -4, 1, 5, 6, -1, and then one more time. So again, by doing this, it'll make our diagonal pattern a little bit easier to find as we're working through our problem. Okay, so to start with, again, we're going to multiply the forward diagonals. So I'm going to take -1 times -4 times -1. So -1 times -4 times -1, and then we're going to add that to the next set. So 3 times 6 times 0, and then we're going to add it to our last set. So 5 times 2 times 1. Again, we're going to group this with its own bracket. And then we're going to do that same process, but with the backwards diagonals. Okay, so again, we're going to start in the middle. So 0 times -4 times 5. And we're subtracting still. So 0, -4 times 5. And then plus the next backwards diagonal. So 1 times 6 times -1. And then our last set is going to be -1 times 2 times 3. So again, we're just going to go through and simplify. So -1 times -4 is 4 times -1 is -4. And then 3 times 6 times 0 is 0. 5 times 2 is 10, times 1 is still 10. And then again, we're subtracting. So 0 times anything is going to be 0. 1 times 6 is 6, times -1 is -6. And -1 times 2 is -2, times 3 is -6. Okay. So again, we're just going to keep simplifying. So -4 plus 10 is 6. And then -6 plus -6 is -12. So we're subtracting a negative, so that means that we're really adding. So 6 plus 12 is 18. So 18 is the determinant for that matrix. All right, our next example. So this time I'm going to use kind of the shortcut pattern to work through it. So I'm only going to rewrite our matrix once. So now I'm going to do the subtraction part right away. So we're going to have -3, 2, 0, 4, -5, 2, and then 0, 1, 3. So again, starting with our forward diagonals, we're going to take -3 times -5 times 3. Okay. So -3 times -5 times 3 plus. And then we want to do the next set. So it's going to be 4 times 1 and then times 0 from the bottom. Okay. So 4 times 1 times 0. And then our last set is going to be 0 times 2 times 2. And then we're going to do that same process with our backwards diagonals. Okay. So 0 times -5 times 0. And then we would have 2 times 1 times -3. And our last set is going to be 3 times 2 times 4. Okay. And again, we're just going to go through and simplify to find the determinant. So negative 3 times negative 5 is 15, times 3 will be 45. And then this will simplify to be 0, and then we'll have another 0. So again, 0 for the first number. And then 2 times negative 3 is negative 6, times 1 is negative 6. And then here we have 2 times 3 is 6, times 4 is 24. So now we have 45 minus, and then negative 6 plus 24 is going to be 18. And 45 minus 18 gives us 27. Okay, so 27 would be our determinant for that problem. All right, one more example. So again, I'm going to do our shortcut again. So I'm just going to rewrite it. So we're going to subtract. So 2, 0, 1, 0, 0, negative 5, negative 1, 0, and 3. So this time when I do the problem, I'm going to simplify my numbers as I'm writing them. Okay, so again, starting with our forward diagonals. So we're taking 2 times 0 times 3. So that's going to give us 0. And then our next set will be 0 times 0 times 1. So again, that's just going to be 0. And our last set, we're taking negative 1 times 0 times negative 5. So again, I'm just going to have 0. And then it's going to be backwards. So 1 times 0 times negative 1 is just 0. And then negative 5 times 0 times 2 is 0. And 3 times 0 times 0 is also 0. So this is going to be an easy one to simplify. So here we just have 0 minus 0, which is 0. So our determinant is 0. Now remember, when we find a determinant of 0, that means that we will not have an inverse for this matrix.